Hello and Assalamualaikum. We are from Group 3, Pistachio. We consist of 4 members, which are Amir Hazim bin Bahri, Faris Awati bin Azrin, myself, Nur Isna binti Muhammad Isa, and Anis Shamimi binti Muhammad Zamri. We are going to present about replacement algorithm for subject SKJ 3103 operating system. For an introduction, what are page algorithm? Page replacement algorithm decides which page to remove, also called swap out, when a new page needs to be loaded into the main memory. Why do we need to swap the pages? Since we have a fixed number of frames and all the process cannot be stored in the main memory at a single time, hence we use page replacement algorithm to store pages of a process instead of the whole process. There are 4 replacement algorithms used. The first one is FIFO. FIFO is referred to the first in, first out. The concept of FIFO algorithm is replace the oldest page which has been present for the longest time in the main memory. When a new page comes in from secondary memory to main memory, it selects the front of the queue, which is the oldest page present, and remove it. Let's see example 1. We have 7 numbers of pages, which contain page stream 3, 2, 1, 3, 4, 1, 2. Remember, page fault involves transfer of data from hard disk to RAM. If a process requests for page and that page is found in the main memory, then it is called page hit, otherwise page fault. Assume the RAM consists of 3 slots only. Initially, the frames are empty. The first number in the page stream, which is 3, will enter the frame. Then, number 2 will be executed in second frame. Then, number 1 will be placed in the third frame. Now, the frame is full. Then, we have number 3 again to enter the frame. Hence, there's no page fault since we use again the number. And here, we got page hit. Next, we have number 4. The number 4 will enter and replace the number 3 as 3 is the oldest numbers or has been present for the longest time in the main memory. Here we got page fault. Next, we have number 1 again as number 1 has been present in the frame, and here also page hit. Next, we have number 2 again and again. We have page hit as the process request for page or number that has been present in the main memory.
So we go to OPT replacement algorithm. For optimal policy is the best replacement algorithm because the results is in the least number of page faults. Select page for which the time to next reference is the longest. So it will produce 3 page faults, and after the frame allocation has been filled. Okay, now so we go to example. Then okay, the number of page stream is 273, 842, 385. So we just simply put 3 first number in the box, just like FIFO. And then, okay, so 273 has been filled. Now we look at number 8. So what number we should replace with 8? Okay, so it should be 7 lah, because if we look at the page stream after 8, there doesn't have 7 anymore, so we replace it. Okay, now we will go to 4. Number 4. So we will replace 8 with 4 because we choose the longest page stream. Number 2 has 1 page time, and 3 has 2 page time, and 8 has 3 page time. So it is the longest. So we change with the number 8. Okay, next. Okay, we go to number 2 and 3. Uh, this number 2 and 3 already in the frame, so we just use back the number and doesn't change anything lah. Okay, then okay. We go to number 8, right? Number 8, yeah, number 8. Okay. Next, number 8 is we look from the top of the frame, which is number 2. In the page stream, there were no number 2 anymore, so we can replace it with number 8. Next, number 5, also the same. We look for the first frame and replace 8 with 5. Okay, and that's all for OPT algorithm.
Okay, the next algorithm replacement is LRU, which is the short form of least recent use. When inserting a new number, if the cache is not full, add the new number to the empty cache. If the cache is full, replace the least recent use number with a new one. After creating a new space, if the new number is already in cache, reuse the number in the new space. Look at the example 1. It has 11 pages. For the first number, which is 5, we can insert the new number into the empty cache, same as the second and the third ones. For the fourth number, it shows that the new number, which is 7, is not equal to the one of numbers that already in the cache. So we can replace the least recently used number in the cache, which is the new number in the new space. For example, we replace number 5 with 7. The process is the same as the next for the next number until 7 space, which is we can see that the new number is the same as the number in the cache, which is number 3. So we can just reuse that number. So this is the second example that we can look.
Clock replacement algorithm. So, what is that? It is a page replacement algorithm used in operating systems to manage memory pages. It is a simple and efficient algorithm that balances between recently used pages and those that have not been accessed recently. The algorithm maintains a circular list or circular queue of pages in memory. Here the example of clock replacement algorithm by using page stream. So here I have 7 pages and each page stream assigned with random numbers, which were 2, 4, 3, 4, 7, 9 and 8. Now let's delve into how it works. But before that, we need to pay attention to the arrow movement and the lock. Okay, let us start by adding number 2 into the first frame and lock it. Then the arrow will be at the next frame, which is second frame below the first frame. Next, adding number 4 into the second frame and lock it too. Then the arrow will move to the third frame and same goes for the number 3. Now, adding number 4 into the frame, but it was already there. As for this case, whereas the same number will be added, if the page want to be replaced by the same number and currently no lock, then add the lock and the arrow will not move. Alright, now number 7 is supposed to be added into the first frame, but was occupied by number 2 and locked. So, if the page wanted to be replaced and has lock, then lose the lock but will not replace and move the arrow. As you can see here, the arrow will travel until the lock removed. Then the number will be replaced, which in this case we got number 2 replaced by number 7 unlocked, and the rest lose the lock. Lastly, for number 9, the work much easier because the current number, which is number 4, has no lock. So we just replace the number and lock it. Same goes as for the number 8. And the final result, we will get number 7 on the first frame locked, number 9 on the second frame locked, number 8 on the third frame locked, and the arrow pointed at the first frame. Now, let's identify fault identification. It is basically occur after the frame allocation is initially filled. So, if we see here, the fault identification occur at frame content number 7 locked, number 4 and number 3 unlocked, as well as frame content number 7 locked, number 9 locked, and number 3 unlocked. This is because there are changes in numbers allocation in the frame.